So now solving rational inequalities, again, sometimes finding the domain can turn into solving a rational inequality. So algebraically, how we do this, I keep saying algebraically because we can do it graphically by graphing the function and seeing where it's below the x-axis or where it's above the y-axis. But you guys don't have a graphing calculator, so you need to know how to do this algebraically. So solving rational inequalities, I have a rational function and I want to solve for where it's greater than 0 or less than or equal to 0. So the first step will be factoring. So I need to factor the top. So what two numbers multiplied together give me -5 and added give me +4? Well, it will be -1 and +5. So this is review from college algebra, how to factor quadratic polynomials. And then 5x squared, so I need this to be a 5x, and then I need this to be an x, and then I have to decide what to put in here. So I want these two numbers to multiply to -15, so I can try +3 and -5, and you can FOIL this and you can see that this is the answer. So this is greater than 0. All right, so now we are going to solve this inequality similarly as we did with polynomial inequalities. We're going to set it up. We're going to find the x-intercepts in the first row. So the x-intercepts are given by the zeros of the numerator. So the zeros of the numerator are -5 and 1. And then I'm also going to I'm going to put the zeros of the denominator. So even though the denominator can't be 0, I'm going to keep track by plotting where it would be 0 and then keeping track that it cannot be that value because I can't divide by 0. So the x-intercepts are -5 and 1, and then the zeros of the denominator are going to be -3/5, which is -0.6. So -3/5, and then 5. Okay, and then I'm going to look at the signs of each of these factors. So x minus 1 is 0 when x is 1, and then it's minus before 1 and positive after. And then the other factor is x plus 5. X plus 5 is 0 when x is -5, so it's going to be 0 here. And it's going to be minus before and positive after. And then the zeros of the denominator, 5x plus 3. 5x plus 3 is 0 when x is -3/5, so it's going to be 0 here, and it's going to be negative before and positive after. And then x minus 5. X minus 5 is 0 and x is 5. It's going to be negative before and positive after. Now, in the last row, I'm going to put the whole rational expression, x minus 1, x plus 5, over 5x plus 3, x minus 5. But now, the first thing I need to keep in mind is that I can't divide by 0. So when 5x plus 3 is 0, right here, I cannot divide by 0. Okay, so then I'm going to put a vertical bar in here. I cannot divide by 0. And then x minus 5 is 0 when x is 5. So in here, I cannot divide by 0. So I cannot use any of those two values in my answer because I can't divide by 0. So that's why I put these vertical bars. Okay, so now I have x minus 1 times x plus 5. That's a minus times a minus. So this is going to be a positive. So it's a positive divided by 5x minus 3 over x minus 5. So a positive divided by another positive. So the answer is going to be a positive. Then for when x is negative 5, I have a negative number times 0. So it's going to be 0 divided by a negative number times another number. So divided by a positive. So a 0 divided by a positive is going to give me 0. So what do we have so far is that before negative 5, I have that the inequality is plus, and at negative 5 it's 0. Now similarly, between negative 5 and negative 3/5, I have a negative number times a positive. That's my numerator, so it's going to be a negative divided by a negative times a negative, so divided by a positive. So a negative divided by a positive is a negative. Now I have a negative times a positive divided by 0. I cannot have anything in here, so this is going to be undefined. And then between negative 3/5 and 1, I have a negative times a positive, so that's going to be a negative, divided by a positive times a negative, so that's going to be divided by a negative. A negative divided by a negative is a positive. So between negative 3/5 and 1, we have that it's positive. Now at 1, I have a 0 times a positive number, so that's a 0. And then divided by a positive times a negative. Well, divided by a negative, but 0 divided by a negative number is just 0. And then between 1 and 5, I have a positive times a positive, so it's going to be a positive divided by a positive times a negative, which is a negative. So the answer is going to be negative between 1 and 5. Now at 5, I have a positive times a positive, x minus 1 times x plus 5, divided by 0. So it's undefined. So undefined. And then after 5, I have a positive divided by another positive, which is a positive. So the answer to where is my rational inequality positive? Well, it's positive in here, in here, and in here. It's strictly positive, so we're not going to include 0, and we're not going to include where it's not defined. So how do we get the answer? Well, we just look what x's are in here. I have, it's from negative infinity to negative 5. And then from negative 3/5 to 1. And then from 5 to infinity, sorry. These are the 3 intervals where we have pluses, and we were interested where is it greater than 0. Alright, so we'll do one more. For this one, it's not in factored form, so we have to bring it in factored form. So what we're going to do is bring everything to the left-hand side. Minus 2 over x plus 9, and it's less than 0. And then we're going to bring to a common denominator. So the common denominator is all of these factors multiplied by themselves. So x needs the x plus 1 and the x plus 9. So it's going to need x plus 1 and x plus 9. x plus 1 is going to need the x and the x plus 9. And the x plus 9 is going to need the x and the x plus 1. Okay, so now the common denominator is x times x plus 1 times x plus 9. And then let's see what we have at the numerator. And this is going to have to be less than 0. So I have a x plus 1 times a 1 times x plus 9. So x plus 1 times x plus 9. Plus I have an x times x plus 9. So it's going to be plus x squared plus 9x. And then I have a minus 2x times x plus 1. So now we just got to do a little more algebra, and then it's going to come down to solving a rational inequality. So we're going to FOIL this, and this is going to give me x squared plus 9x plus x, so plus 10x. And then plus 9. And then plus x squared, this should be squared, plus x squared plus 9x minus 2x squared minus 2x squared minus 2x. Okay, I have 2x squared minus 2x squared. The x squared goes away. I have a 10x plus a 9x. That's 19x minus 2x. That's 17x. 17x, and then the only thing I have left is a plus 9. So now our task is to solve this rational inequality. So one more time, I'm going to put the x-intercepts in here and the zeros of the denominator. The x-intercept is negative 9 over 17, and that's negative 0.52. So negative 9 over 17. That's the x-intercept. The zeros of the denominator is going to be x equals 0, x equals negative 1, and x equals negative 9. I'll have to redo this. So I redid this. So we're going to put the x-intercepts and the zeros of the denominator. So from the x-intercepts, we got negative 9 over 17. X equals 0 from this one, x equals negative 1 from that one, and x equals negative 9 from that one. So now we're going to do our algebra. So 17x plus 9. This one is 0 for this, and it's negative before and positive after. The next is for x. Well, x is 0 when x is 0, and it's negative before 0 and positive after. Then the next factor is x plus 1, and then x plus 1 is 0 when x is negative 1, minus before and positive after. And then the last factor is x plus 9, and this one is 0 and x is negative 9. It's negative before and positive after. Okay, and now the answer. So another way to do this, no, let's just keep it like what we did before. So in here, I'm going to put 17x plus 9 divided by x times x plus 1 times x plus 9. So it's going to be a negative divided by a negative times a negative times another negative. So a negative, so from these three negatives, we get that it's a negative denominator. So the answer is going to be negative. Then at negative 9, I have a negative number divided by a negative times another negative times 0. So x plus 9 is 0, so division by 0 here. So we're going to get undefined in here. So undefined because x plus 9 is 0 here, and we can't divide by 0. Alright, then between negative 9 and negative 1, I have a negative divided by a negative times a negative times a positive. So a negative divided by a positive. So negative for 17x plus 1, and then a positive, because a negative times a negative is a positive, and times another positive is a positive. So we're going to have a negative between negative 9 and negative 1. At negative 1, again, we're going to have division by 0, because x plus 1 is 0 there, so it's going to be undefined. Between negative 1 and negative 9/17, I have a negative divided by a negative times a positive and times a positive. So it's a negative for the top and then a negative for the bottom when I multiply all these three together. So it's going to give me a positive. At 9/17, I have that the numerator is 0 and then the others are either negative or positive. So 0 divided by a negative number is 0. Between negative 9/17 and 0, I have a positive for the numerator, and then divided by a negative times a positive times a positive, so divided by a negative. So I get a negative. At 0, I have that the denominator is 0 because x is part of the denominator, so we're going to have undefined at 0. And then in between 0 and infinity, they're all positive, so it's going to be a positive. So the answer now to our inequalities, where is this less than 0? Less than 0, it's for here, and for here. Oops. That's where we got that it's negative. So looking at our x's, that happens between, so negative infinity to negative 9. That's the first interval. The second interval is negative 9 to negative 1. And then this interval happens for negative 9/17 to 0. And the reason they all have parentheses, it's because this was strictly less than 0, so I couldn't have included this 0. So I couldn't have included negative 9/17, and also I couldn't have included negative 9, negative 1, or 0, because that will make the denominator 0 and we can't divide by 0. So this is the solution to our beginning inequality, which was 1 over x plus 1 over x plus 1 less than 2 over x plus 9. So this is what we started with, and how did we do it? We subtracted this, and then we brought to a common denominator, and we turned it into a polynomial, into a rational inequality to solve, and then we solved this one by doing the table and testing the sign of each factor individually. This is probably new for you guys, so I strongly recommend you watch the video, send me questions if you have questions, if something is unclear, and then practice with the homework.